Well, hello there, amazing geometry humans. It's Miss Waite with another video for you. What you don't know is this is about the fourth try that I've tried to make this video. So if I sound a little out of breath, it's because I had to run down batteries from my microphone. But here I am, and here you are, and let's get going. So the first thing to do is to get out your notebook. Um, we're still kind of every day looping back before we take new notes. You're looping back and reviewing your old notes. And so what you're going to want to do is get back to that first page where you have not written questions. And that's going to be maybe just the last set of notes, but maybe it's further back because you haven't reviewed in a while. So get in there and get some of those questions written for your notes. Remember, you chunk your notes and you write a question for each chunk. And maybe that's 3 to 5 questions on the page. Maybe it's more, but it definitely shouldn't be less. And then you probably have to turn back 2 pages in order to find a page that doesn't have a summary. Maybe you have to go back further because you're not writing your summaries. Your summary is your answer to your essential question and really takes the information on the page and boils it down to a couple of ideas. And it can be very helpful in remembering things, especially when you're taking a test. So write yourself some summaries. You can pause this video and get that business done and then come on back. All right. So here we are. We're working our way forward. I just want to remind you that you are not alone in this process. Sitting there watching a video, taking notes, doing assignments can really feel like you are. And I want to remind you that I'm available to you to give you some personalized help if you need it. You hybrid lovelies, you have in-person class times where please ask questions, because if you're asking questions about the assignments, other people are glad you did, and we can talk through some stuff together. But there's also office hours, and you are more than welcome to come to those. You VLA fabulous human beings, you have optional class times, and for this class, it's Wednesday and Friday from 11 a.m. to 11:30 a.m. and you can pop in there and I can give you some help. And also you are more than welcome at office hours. All the office hour information you need is on Google Classroom. If you go to the classroom page and you'll find entry for office hours, click it and you'll have everything you need to get into some office hours. So don't struggle in the dark, friends. You can do this, but you might need a little help sometimes. Okay, so here is your essential question of the day. How can you use notation to express geometric concepts? And your topic is more geometry notation. What you want to have now in front of you is a blank sheet in your notebook. You're going to be writing that topic, more geometry notation at the top. And then right underneath it, you're going to write the essential question. How can you use notation to express geometric concepts? And from there, you're going to draw lines so that you have a column for notes, a column for questions, and then a summary rows at the bottom of the page. And so it might be worth pausing your notebook and pausing your notebook, pausing the video and getting that set up. Oh, but before you do, don't forget your topic also goes into your table of contents. And so as this table of contents grows, you can start to see the logic of keeping track of the topics that we study so that you can find them easily. Okay, now pause the video, work on your notebook, and then come on back. Okay. So let's just do a quick review. We have talked about points, lines, and planes, and this isn't necessary to put in your notes because it likely already is. A point is essentially a location in space. That's a good description of it. A location in space. Now, the reason why we say that this is a description rather than a definition is because these 3 words, point, line, and plane, are considered to be geometry's undefined terms. And the reason why that is because of the definition of definition, which we're not really going to get into. But these words aren't able to fall under that category. And so the best we can do is describe what they are. And a point is best described as a location in space. And you can draw it by drawing a dot. That's what a point looks like. Now, a line is when you take a bunch of points and you line them up together, and that's where we get that word line, is because we're lining up these points. And there's ways to describe lines, but one way that I like to think of it is that it is an infinite arrangement of points. Now, there's lots of things that could be infinite arrangement of points, but if you think about it in terms of a drawing, you can see that in between those two arrows that indicate that that line goes in both directions infinitely, that in between is an infinity of points. There's no distinct points. We can pick out a couple of those points by putting dots and then labeling those dots to say that point A and point B are on that line, line AB. Now the other thing that we want to talk about is a plane, and a plane is also, if we took a bunch of lines and we laid them side by side and none of them were sort of, not parallel to the others, we might have a plane. And so we can describe a plane as being an infinite arrangement of lines. Now there's lots of arrangements of lines, and so this isn't a great definition, but it is kind of a neat description, because if we draw that and we take a bunch of lines and we put them next to each other and we understand that they go forever and ever, we might have a plane. So that's how I remember these things. I think of a point being the smallest thing that there is in geometry, and then if you put them all in an infinite arrangement right next to each other, you have a line, and then if you take a bunch of lines and you lay them next to each other so they're all parallel, you have a plane. Okay. Another bit of review is the symbols that we've been talking about. And just like I talked about before, when you want to symbolize a point, you use a dot. Point P is a dot. And when you're writing it in a sentence, you just use the letter. If a letter is sitting there by itself, I'm going to assume that that's a point, that you're talking about a point. When you're writing about lines, you're going to put a line on top. You're going to pick 2 points on that line, in this case AB, and you're going to put them next to each other and actually draw a little line on top of them. When you're talking about a chunk of a line, you're talking about a segment. And we could just be talking about segment AB, which is not going to have any arrows. And then there's ray AB, which has an arrow pointing to the right. And what this tells us is that there is an end point of ray AB at A, and then it goes out through B. There's something to think about for rays. Because the arrow points to the right all the time, ray AB and ray BA are not the same thing. Ray AB could look like this. Starts at A and goes out through B. BA could look like this. Starts at B, goes out through A. Rays, as far as notation goes, are pretty specific, and it's telling you a lot of information. So the more practice, the better. So let's get into talking about symbols just a little bit further. Now, I've got a note over here. Drawing figures in your notes is a really great idea. It doesn't have to be pretty. Take the time. You're going to thank yourself later. So this diagram that we have here, we've got this parallelogram that is indicating a plane. We've got a line that is right in it, and then we've got another line that kind of goes through it. And we're going to use this diagram to pick some the pieces that we're being asked for. So part A says, give 2 other names for line PQ and plane R. So let's start with PQ. Now, PQ is this line right here. I'll just trace it. There's line PQ. Notice that we could call line PQ line QP. We could just reverse the direction and have, reverse the order and have another name for that line. Notice also that there's this little letter hanging out next to the line with no dot next to it. That is actually a name of the line, and we could say line N. And so there's 2 names for PQ. Now we could give 2 names for plane R by picking 3 points on that plane. Notice that R is not a point. How do I know that R is not a point? I'm being like Dora. That's right, because there's no dot next to it. It's just a label. It's a label for that plane. But we could call that plane something else. We just need to pick 3 points. So we could call it, I don't know, how about VST? We could also call it PTS. Those are 2 great names for plane R. Part B, name 3 points that are collinear. Now this is one of those words that I had you write in your notebook, collinear. And this is, you have the ability to break down this word into 2 parts, co and linear. Co always means together. Linear always means line. So when you look at this part, co, together, there are other words that have that part in it too. Community, community. Cooperative, cooperative. Community means to live together. Cooperative means to work together. Co always means together. And then this linear part, line, we can see that that word collinear means together on a line. And so what you're going to do is you're going to name 3 points that are on the same line. That's what collinear means. 3 points on the same line. Well, I'm noticing that S, P, and T are 3 points on the same line, and so I'm going to list them, S, P, and T. So then we can also name 4 points that are coplanar. So again, we have this co part, which means together. And then we have planar, which means on a plane. And so being coplanar means that they are in the same plane together. So can you name 4 points that are in the same plane? I'm going with V, S, P, and T. Those 4 points are all in that plane. Last one, name a point that is not coplanar with points V, S, and T. So here's V, S, and T. Now there's only a couple of choices here. There's point P and there's point Q. Which of those is not coplanar with V, S, and T? If you guessed Q, you guessed it right, because that one is kind of hanging out above that plane. It's not in it. All right, let's do another example type thing. So here's another diagram to get in your notes. This one's a little easier to draw. Now I'm going to give you a little think time on this. Give another name for segment GH. Find GH and give another name for it. I'm going to go with HG. That's really the only other possibility. We don't want to say J, because J is not an endpoint, and when we're talking about segments, we have to talk about what their endpoints are. So we can reverse the order, and that's okay. Name all rays with an endpoint J. So here's a ray that starts at J. What would that one be called? That would be called JF. Here's another ray that starts at J. That one's going to be called JH. Notice that I'm putting the J first every time because that is the end point. And then here's another one, JE. And then our last one, JG, looks like this. Okay? Which of these rays are opposite rays? Opposite means that they point exactly in opposite directions, completely opposite of one another. So let's see. If we just look at JF, which ray is directly opposite JF? Is it JG? Is it JH? Or is it JE? Which one points in the exact opposite direction? If you guess JE, you're correct. And so which of these rays are opposite rays? We have JF and JE are opposite rays. There's another set, though. I bet you see those. Here's JH, Pointing in the exact opposite direction is JG, and so we can indicate those as well. JH and JG. Those are opposite rays. All right, last question. Are JE and EJ the same ray? Let's stop there and think about that. Are JE and EJ the same ray? The answer is no. And the reason why is because one starts at J and goes out through E, and the other one starts at E and goes the other direction through J. And those cannot be the same ray because they're actually going in opposite directions of one another. What about EJ and EF? EJ starts at E and goes out through J. And then EF starts at E and goes out through F, which also kind of goes through J. Are those the same ray? Yes, they are. You could call it either thing. They have the end point of E and they go in the same direction. EJ and EF are definitely the same ray. Okay. So that's kind of it. It's digging into pictures and picking out those geometry objects and writing them down, being able to name them. So your topic today was more geometry notation. Now today's your first practice on Big Ideas Math, so you'll log in there and you'll find the assignment. It's the only one, and I haven't actually put it on Big Ideas Math at the time of this recording, and so I'm not sure what to call it, but it'll be the only one. So get in there and do that assignment. Your essential question, how can you use notation to express geometric concepts, should be answerable at this point. If not, that's how you know you need help. All right, you guys, thanks for listening. Thanks for watching. Thanks for being amazing geometry students. And I will talk to you again sometime soon. Take good care. Bye.